Okay, in this podcast, I'm going to describe problem number 2 on your practice sheet. In problem number 2, I asked you to do something slightly different. I gave you just a source table with some values in it. I didn't give you all the raw data, but I'm asking you to calculate the F value and decide whether you should reject or fail to reject the null hypothesis. So it says, a psychologist compares, I have a mistake in there. A psychologist tests a new drug called JCK on symptoms of depression. To test the drug, he compares it to 3 other conditions: a placebo, another leading drug already on the market, and the absence of any drug. Each condition has 10 participants. State the null and the alternative hypothesis, complete the following table, calculate the F value, and decide whether you should reject or fail to reject the null. So here is our source table. And you can see you have the sum of squares total and the mean square for within already in the table. And just with those 2 values and the information in this problem, you should be able to fill in the rest of your table here. So the first thing we want to do is state our hypotheses. The null would be, again, that all of the conditions are going to be equal to each other, or there is no difference between them. The alternative is that at least one of the population means is different from the others. The next thing that you want to do is find your critical value. So with an alpha of 0.05, you will need that information plus your degrees of freedom to find your critical value in the table. So you need to go to the source table and start filling in your degrees of freedom values. Now, you will be able to get the degrees of freedom based on the information in the problem. So, you know that degrees of freedom between is k minus 1, and k is the number of conditions. So you know you have the drug compared to 3 other conditions here: placebo, another drug, and the absence of any drug. So this would be 4 minus 1 equals 3. So that was 3. Then for degrees of freedom total, you know that is calculated as n, which is the total number of participants, minus 1. In here, you already know that there's 4 conditions and there's 10 people in each condition. So 10 times 40 is your total number of participants. 10 times 4, which is 40, minus 1 is 39. And then finally, you have degrees of freedom within. So this is n, total number of participants, minus k. That is 40 minus 4 equals 36. You could also get this because you know the total is 39 and one of the degrees of freedom is 3. 39 minus 3 is 36. Then you're going to look up those values in the critical value table. So we had the degrees of freedom on the numerator was 3. All the way down to degrees of freedom in the denominator is 36. You can find that value here. It's 2.86. Okay, then the next thing we want to do is start filling in our other values. Now, the first thing that you can do is look across to do your sum of squares. In your sum of squares, you can see that you already had your degrees of freedom filled in, and you had a mean square of 2 here. Now, you know that if you divide your sum of squares by your degrees of freedom, you'll get mean square. So you can also work that the other direction. Instead of dividing, if you multiply your mean square by your degrees of freedom, you'll get your sum of square. And you can check this going the other way. So if you take 72 minus 36, you'll get 2. Then for your sum of squares between, remember that these 2 values need to add up to 96. So you can take 96, subtract out 72, and you will get 24. The last value that we need to calculate is mean square between. Mean square between Like I said, you could go backwards here. You can do the division here. So we calculated this to be 24. You divide by your degrees of freedom, which is 3, and that will equal 8. So now we have filled out our source table, and we can calculate our F value. Remember, our F value is our mean square between divided by our mean square within. So 8 divided by 4 is 2. The next thing that we need to do is step 4, which is make a decision and write an interpretation. Our calculated F value was 4, which was greater than our critical value, 2.84, so we reject our null hypothesis and say that there is an effect. The effect of the 4 treatments on symptoms of depression was significantly different. And we put in our between and within degrees of freedom, our calculated F value, and we say P is less than 0.05, which was our alpha. At this point, you would also want an effect size. Because effect size is kind of complicated for ANOVA, I'm not asking you to calculate effect size on the test, but I do want you to know the different effect sizes, and I want you to know when you use them and how they're calculated, or what goes into the calculation and what the numbers tell you, but I'm not going to ask you to do the calculation. I'm just going to ask you to interpret the numbers. One of the things that you will need to know for Tukey's HSD is I want you to know how to get Q, which is in the formula for that, and is a part of the interpretation of that formula.